Hello, my name is Enoch Asanda, presenting a presentation on explainable artificial intelligence in deep transfer learning for skin disease diagnosis under Group 19 in under Makerere University. The table of content shows the flow of my presentation. Skin diagnosis is a form of treatment or kind of treatment in a process of identifying or examining a condition or nature of an illness. In particular, we're looking at skin disease in this context from its symptoms and signs. This is received by an individual from a health expert or an enhanced and sophisticated computer or machine, just like those two pictures down there. Between these two entities, between the human expert and the sophisticated computer, an accurate diagnosis is critical for numerous reasons, which we shall talk more about. So if we specifically focus the diagnosis under a human health expert, we figure out that there will be a high chance of presence of misdiagnosis. While if we specifically focus on the diagnosis using a computer agent, there is low chances of misdiagnosis because most of these computer agents have models which are well trained, have undergone training and testing on multiple occasions. Between these two entities, there is a gap of misdiagnosis that needs to be curbed or filled or attacked or settled. And especially if we look at it starting from the human health experts. And this is why we are using explainable AI and deep learning concepts to come up with computer models that are accurate, efficient, and improve performance of health experts of skin disease diagnosis in real world. The problem statement. Skin diseases cause a huge burden in the globe context of health. And based on a scholarly research under K. Urban, dermatological illnesses have emerged among the top 5 prime triggers of non-fatal applications. Yes, we have a skin disease under investigation or under diagnosis. In our we put it under diagnosis. Depending on the result of the diagnosis, if the diagnosis is a misdiagnosis, it will lead to a wrong prescription by health experts of prescriptions to their patients. And this wrong prescription of drugs or remedies might lead to prolonged suffering or outbreak of the entire skin disease all over the body, or even death and irritation and agitation. So now this becomes a serious burden when skin disease diagnosis is a misdiagnosis. The problem tree is a graphical and structural representation of skin disease misdiagnosis. And in particular, here we're looking at it actually really attacks the human health expert, in that this human health expert, when he's doing diagnosis, there's time consuming due to extensive tests, lack of time with patients, because if this human expert is not so close to the patient, won't be able to get the required information. The level of experience of this expertise might lead to also misdiagnosis, and the nature of the test, due to the fact that these most human experts might not be exposed to hard kinds of test, and then lack of access to high tech. For example, the picture previously shows that an individual is using test tube to carry out diagnosis, and that is, as a result, this leads to confusion in patients. Confusion results due to the fact that the patient has received our prescriptions, but the prescriptions are not really working the way they wanted it to work. Anxiety, the fact that the results which patients are anticipating are not really showing, or they're not really giving them a way like they're working. Prolonged patient affliction on in all that. Research scope. The scope of our research encompasses a group of 10 skin diseases taken from a Damet online source, where we are looking at in specific vascular tumors, systematic disease, bullosa disease, and many others. So the techniques to be used will be explainable AI techniques such as layer-wise relevance propagation, anchors, and specifically we shall be tackling the GradCam, which will make our model transparent, deep transfer learning, the heart of machine learning, and convolutional neural network, the type of deep transfer learning that will be applied. Related works. According to literature review, under J. Carlegos and S. Gabriela and many others, skin conditions affect 1.9 billion people. In many cases, this is seen by physicians with lower diagnostic accuracy. Like I said, the human experts, they are more prone to misdiagnosis, so they'll be able to witness this. And according to reports published by National Center for Biotechnology Information, the cost of treatment for people with skin cancer, when we look at here skin cancer, we could relate it to a skin disease, and it's over $1 billion, and over 5 million people experience serious side effects, such as loss of hair, infections, itches, and burns. Research questions. Our research therefore seeks to use explainability of machine learning algorithm as well as deep transfer learning to realize deep understanding towards finding possible acceptable solutions to the subsequent questions. How can deep transfer learning be used to improve predictive accuracy in diagnosis of skin disorders? How can explainable artificial intelligence be applied to the field of dermatology to increase adoption of artificial intelligence methods in general? How can deep learning be used to automate diagnosis of skin diseases using imagery data? To what degree can explainable artificial intelligence justify deployment of a skin disease model, skin diagnosis model for public use by dermatologists? Those are the research questions. And our research objectives seek to orchestrate a trained model for diagnosis of skin disease. So one of the specific objectives will be to pre-process and prepare the dermatology dataset for model training, as well as make the pre-processed dataset available for further research and researchers in the community to test and evaluate the deep transfer learning model, hence precisely determine how good the model is at diagnosing various skin diseases from in a sample space of 10 classes. To deploy interpretability and explainability using explainability artificial intelligence techniques like layer-wise relevance propagation and GradCam for understandability of the land skin disease imagery features. To also justify model prediction using explainability methods and deploy the model in a mobile application that can be used by health personnel. Now, at this point, this objective is curbing the gap between the human expert and machine. So The methodology. So we're going to employ the use of deep learning, which is the heart of machine learning, and it has been tremendous. It has a tremendous role in image classification in various research domains, specific, as we can see specifically in this field of recent research also show that convolutional neural network, which is a type of deep transfer learning, is very good at detecting many diseases. And also it is very important in data preprocessing. So initially, we shall have a data set which will be needed for training and validating the model. Data will be obtained from public portal domains. Image data shall be passed through a preprocessing pipeline, which comprises the following processes: resizing, normalizing, and image augmentation. So the image below here shows the architecture in terms of graphic. So we get the data set, let's say a single image, we pass it through the pre-processing pipeline of techniques, resizing, pixel normalization, image augmentation, and then we pass it to our model VGG16, which is a model under convolutional neural network. And we shall do a feature extraction by freezing the hidden layers or the zero layers of the model. After that, we shall get the skin disease detection we shall do the disease detection by evaluating and testing from the predictions we gained from the model. And then we shall pass it through an unexplainable AI technique, which we refer to as GradChem, in terms of heat maps and class activation maps. Expected results and discussions. We shall have a fully trained, tested, transparent, and trustworthy deep learning model that is fit for diagnosis for different skin disease from the sample of 10 classes. The use of explainable techniques, particularly GradChem, should enable the model to be transparent by providing explanation as to why and how it has made its predictions. For example, the image below, a class activation map and heat maps. The future research direction, we're looking forward to contribute to open source community or use of more explainable techniques for the same problem to increase the area of application and examine better accurate methods. Engage dermatologists and other health experts to add their knowledge and understanding in cooperation and refining of the model. References, basically that's the reference for our data, our dummy data. And then before the video ends, I would like to give acknowledgement to Mr. Galwango, our supervisor, who has been guiding us and directing us on how to carry out this research and make sure that it adds contribution to a research like this one.